Hello friends, we will solve this GATE example asked in the 2008. Now this is relation A, B, C, D, E, P, G, and we have given the functional dependencies and we have four options. We have to find out the normal form of this relation. Okay, so now before that we have to find out which are the prime key attribute or non-key attribute. Okay, so how to find out? We have to find out the primary key. So let's start with first AB. Okay, so we will find out AB closure. If we find out AB closure, then what we will get? We will get AB determines AB. Okay, so AB determines CD. So I can write here CD. Again, understand C determines E. So I can write here E. And DE determines P. So I can write here P. Okay. Again, B determines G. So B determines G. So I can write this AB closure. Okay. So if you found out AB closure, then AB closure determines all the attributes of relation A, B, C, D, E, P, G. That's why we can say that AB is a candidate key. Okay. Or it can be a primary key. So let's check. Can we found more key like this? So if we start with DE. Okay. So D determines P. Okay. So find out DE closure once again. So D determines DE and DE determines P. Okay. Now P determines C. Okay. Then C determines E we have. Again we don't have. Okay. So we are covering DE, PG, but we cannot conclude here about AN. Okay. So this cannot be a candidate key. Okay. So now we will start with C. If we start with C, P, B, so still in this case will not be getting. So key is only one, that is the primary key is what we can say that AB. So now when we understand that AB is a candidate key or a primary key, so we can understand that the prime attributes are, okay, so here prime attributes you can say that prime key attributes are A comma B. Okay, now we will find out the transitive as well as partial functional dependency in this example. So let's start with this first functional dependency. So here this is key, okay, super key or key or primary key. So here we don't have any transitive as well as partial functional dependency. Okay, now D determines P. Okay, so in this case D is not key and P also not key. So here relation between non-key attributes. So we can say that this is transitive dependency. Okay, so now again C determines C. C is also non-key attribute, E is also non-key attribute. So we can say that this is again transitive dependency. Okay, so again P determines C, again this is transitive dependency. Okay, and B determines G. So B is a part of key and part of key determining non-key attribute. In that case we can say that this is partial functional dependency. Okay, so in this case we can say that when the given relation is in 2NF, when it is in 1NF, and it should not be free from, it should be free from partial functional dependency, that is lowest. Okay, so now here partial dependency exists means what? That is also not in 2NF. If it is not in 2NF, again it is not in 3NF because it is not in 2NF. Okay, again one reason is it is having transitive dependency, so it cannot be BCNF. So it is in 1NF, not in 2NF is the correct option. Okay, so the option is C. Sorry, D, not in 2NF. Okay. Okay, look at this another example asked in GATE 2005 IT. Okay, in this case relation is given having attributes F1, F2, F3, F4 and F5, and we are having functional dependencies. F1 determines F3, F2 determines F4 and F1, F2 determines F5. We have to find out whether this relation is in 1NF, 2NF, 3NF or none. Okay, so now first thing we will do is we will find out the key candidate keys for this relation. Okay, so now if we find out F closure, then what we get? F closure is only F1 and F3. Okay, so now we will have F2 closure. What is F2 closure is? F2 and F4. Okay, now if we find out F1 and F2 closure, okay, so then what we get is we get all the attributes because F1, F2 by default. So F1, F2 determines F5. Okay, then again F1 determines F3 and F2 determines F4. In this way you can understand we can determine all the attribute. So F1, F2 is what? Primary key, or you can say candidate key. Okay, so CK candidate key is F1 and F2. So now we have to find out partial dependency as well as transitive dependency. Understand F1, F3. So F1 is part of key attribute, so hence it is partial dependency. part of key determining non-key attribute. Again, F2 is part of key, again partial dependency. So if it is partial dependency exists, then relation not into NF, then option must be 1 NF. Okay, let's check F1, F2 determines F5. So here is a key, so no other transitive or partial dependency. Okay, in this case we can say that this is partial dependency exists, so relation is not into NF, so it must be in 1 NF. Okay, so thank you very much for watching the videos. We will solve more GATE examples and we will learn different things. I will also tell you the shortcut technique as we are learning in decomposition, normalization, finding out the lossless join, etc. If you like this, please subscribe my channel with notification icon button, and if you have any comment doubt, you can write in the comment section. So thank you very much.